Hello everyone, and welcome back to another edition of Index at Office Hours. Today is the 14th of February, a very special day, also known as Valentine's Day, and is also Index at Office Hours 94. This is the town square for graph ecosystem participants to come together to discuss the most important topics for indexers. If you are new to this call, welcome. We love participation. This is a conversation. So at certain parts of today's conversation, please do contribute via voice or text. And if you're having issues unmuting your mic or contributing via voice, please mention it in text and we can try and get that sorted for you. Just as a reminder, this is going to be recorded and distributed onto public channels like YouTube. So if you are concerned about privacy, please bear that in mind. And with that, let's get into today's agenda. So I'm going to give a shout out to Nick at 𝗨𝗂𝗧𝗧, who interviewed the co-founder of Request Network and Request Finance. So if any of you are curious, Request Finance is the all-in-one finance solution for Web3 businesses and a very highly used invoicing and payroll solution for the crypto industry. So this interview is interesting because Christoph discussed his background in finance, also being a CFO for a startup in Geneva, and he kind of discussed his general interest in international payments and processing that led him to Request Finance. Also, he spoke about his entrepreneurial journey. I know Nick is a fan of asking people about how they have come to start their companies, and he had a very interesting story as to how he started Request Network and Request Finance. And he also spoke a bit about like the target users of those particular products. And then finally, they discussed obviously the graph and what his opinions are, Christoph's opinions are on the future of DeFi and how it can impact the worlds of accounting, finance, and audits. And so if you're interested in any of those topics, I would highly recommend checking out the episode. As we can see, thank you, Nick. He has posted it in the chat there. And with that, I'm going to hand it over to Anna, who's going to take us into our regularly scheduled Repo Watch section. So Anna, please take it away.
Thank you, Abel, and happy Valentine to whoever is celebrating, and happy anti-Valentine to whoever is anti. I'm probably more anti, if anyone cares to know. Anyhow, so on Repo Watch, it's quite light this week, but we have had new releases for Streaming Fast. Streaming Fast Near. So new release version 1.04, which just updates workflows to use Ubuntu 20.04, and another release from Streaming Fast Near 1.05, which adds support for this command utility, which I don't know how to pronounce, but it's basically S3 CLI. S3 CLI to download the Docker bundle image. Then on Nethermind, we have had a new release. So this is release version 1.17.0. This is marked as an unstable release. For us, this release, it's marked as an unstable release, so we probably don't want to upgrade to it at the moment. But some of the changes, there have been a lot of changes to the Shanghai hard fork, so a lot of support for that. New updates to proto-dank sharding, so possibility to set different chain IDs and network IDs in chain spec, and a few other features. To JSON RPC, for Nethermind, we have had a trace block, so adding zero reward post merge similar to pre-merge, reducing RAM consumption for trace block, and increasing JSON RPC max batch size to 1024. So this is related to the small issue with Prism, where Prism can send a little bit more than 1,000 requests in a single batch. So they just adjust the behavior to meet that Prism issue until a new Prism release will be released. On the sync and networking side, there has been a fix for an edge case on beacon headers, causing syncs to hang until a better peer is found. There have been fixes to establishing a connection on eth67 and a fix for an edge case when transitioning from fast sync was buggy. For transaction pool, there have been a fix for edge case scenario where nonce incrementation is executed multiple times for method it send transaction. And there have been a lot of performance improvements on this Nethermind release. So garbage collection, forced garbage collection when visited state try to reduce memory pressure in full pruning, forced garbage collection after syncing, after finishing sync stages, reduce memory allocation, limit memory allocation, plus a lot of other code optimizations. So yeah, massive change log. However, the release is marked as unstable. If anyone has tried it, please let us know. We understand if you haven't. And this is all we have for execution layer. Looking at consensus layer clients, we have had a new release for Prism, so release version 3.2.1. This comes with known issues related to 𝗨𝗀𝗃𝗀𝗀 upgrade. However, I won't go into that because it's not necessarily relevant to us at the moment. But some of the things that have changed, so Prism CLI utility support for exiting, Beacon API improvements, Prism API improvements for getting block RPC, some fixes, so multi-client end-to-end, some sparse Merkle tree bug fix, and a few others. But what you need to know on our side is that Prism version 3.2.1 is a recommended upgrade for girly and mainnet nodes and for validators, and it's mandatory for people running other chains, but for us it's just recommended. And that is everything I have for this week. Does anyone have any questions? Has anyone tried any of the 3 releases we touched upon? I can see Matthew is typing, so have not tried any. Okay, well, and I think that's the case with most people. Handing over to Juan. Thank you.
Can you hear me? Yeah, I think so, right?
Yep, loud and
Awesome. Thanks, Anna. Getting into Protocol Watch, we have a few updates for firm governance, a few new GIPs, mainly number 41, A World of Data Services. This is not a new GIP. It has been there for a few months, I think. But Giannis restarted the discussion about like possible ways to implement this. This is like a huge kind of like new feature that would allow the on-chain consensus to actually also serve different data services like Firehose data or just RPCs or other stuff other than subgraphs. I think also substreams in some form. There's a lot of discussion about how to implement this because, again, it's a huge upgrade that it's intended to not disrupt future contracts or not require a lot of different new changes in the future. So yeah, it's a pretty nice discussion. Then we get into the updated some protocol parameters due to post-merge reuse block times thread. Thomas just mentioned that the transactions were executed by the council now, so those are now updated. After that, we have GP43, which is activate indexing rewards in the graph network on Arbitrum 1. There's been some support for the 5 to 10% L2 indexing rewards initial values. So basically, starting the activation of indexing rewards in L2 with like 5% of the total, 5 to 10% of the total indexing rewards across both chains would be on L2, ideally. Up next, we have 𝗨𝗂𝗂𝗧𝗂𝗂, which is the L2 migration helpers. This is a huge thread regarding the all of the different kind of like helpers that are being implemented to make the migration from L1 to L2 a lot simpler, and in some cases even possible. One of the issues is also, like, for example, vesting contracts. That wouldn't be possible with because you can't take out the still locked tokens, so the migration helpers are actually required in those cases. But in other cases, it does help make the transition from, like, for example, bonding curves from L1 to L2 a lot more seamless. Hopefully, that's the idea at least. Then 𝗨𝗂𝗂𝗧𝗂𝗂, which is a proposal regarding potentially enabling a change for the beneficiary of the vesting contracts. There has been a lot of discussion because, as far as I understand, this is not even viable because those contracts are actually immutable. But some of those concerns regarding the vesting contracts, particularly for L2, are sort of like mitigated with the 46, like the migration helpers that we just discussed. So there's some discussion about whether that's kind of like enough for the proposal itself, whether that's a viable alternative or not. But yeah, there's a lot of discussion there. Next up, 𝗨𝗂𝗂𝗧𝗂𝗂, enforce minimum indexer stake across all indexer actions. There was a question about whether there are other actions other than slashing that can cause this edge case. As far as I understand, it's mostly slashing, but it's kind of like an upgrade to make sure that it does not happen at all in any other potential edge case, as far as I understand. Going into forum research, we have no new updates since last IOH. And into contracts repository, we have the huge work in progress for the stake and delegation migration helpers for L2. Again, the migration helpers, both the GIP thread in the forum as well as the contracts repository update. That's kind of like a huge update. It's quite tricky to code some migration helpers for these because it's quite tricky to maintain the state and like move the state from one place to the other without like disrupting anything, particularly for curation because of the bonding curves and stuff. So yeah, if anyone's interested, all of the links are available in chat as far as I can see, and also in the agenda. Next up, the network subgraphs. We have no new releases for any of them, so that would be all for Protocol Watch. And I'm going to hand it over to Abel now.
Wonderful. As always, thank you, Anna, and thank you, Juan, for the updates. So Pedro is not with us today, so I'm going to go ahead and paste the updates as it relates to, that's a lot of updates, as it relates to MIP. So please do check it out and go ahead and read the links that are available. Read the message and check out the links that are available there. Also, another thing that's worth mentioning is there is something that's happening in the Ethereum ecosystem that's quite important. It's the 𝗨𝗂𝗂𝗧𝗂𝗂 ceremony. Let me just go ahead and find the link here so that I can share. If anyone has a link handy, please do share in the chat. Bear with me one second. I had the link right here. Oh, there we go. Thank you, Chris. There is an error with yes, that is in the message, Nick. If I'm not mistaken. Actually, Nick, do you want to go ahead and speak to that point there in case I've missed anything?
Yeah, it's just that update indicated that Arbitrum starts and it actually ended, so I'll make that amendment.
Got it. Yes, that's very important to make that clear. So yes, thank you so much there, Nick. Yeah, we obviously have the ZK summoning ceremony, which is a very important step for the security and scaling of Ethereum. And so I just wanted to kind of mention this. Actually, Alexi was the one who pinged me about this, and I thought it was a great idea to mention this in IOH. And if anyone has the ability, we would highly recommend engaging in this. There is obviously a wait time, and participants are picked randomly, but there's several thousand people who are currently waiting. But I would definitely recommend getting involved in that, because not only are you contributing to the security and scaling of Ethereum, but also in the future, there's a chance that we could use these types of ceremonies in the graph ecosystem for some cryptography related things. So actually going through the exercise of getting involved here could be beneficial. Yeah, if there's anything else anyone wants to add to this, please do. It is an Ethereum-wide ecosystem initiative. Maybe Chris, we had a discussion on this. Would you like to say a few words on this, or should we leave it as is? I see you typing.
I think we can. Yeah, I think you kind of covered it quite well, and the ceremony page at least describes what it is and why it's important. If we get to the open discussion section and people want to talk about it, we can definitely do that.
Wonderful. Well, there you go, guys. The link is in the chat. Thank you, Chris. So yeah, please do check it out. Amazing. Now we get into a very big part of today's conversation. We're lucky to have Matthew on the call. And Matthew, if you guys know, gave us a presentation or a workshop on Firehose the first time, and it was an absolute hit. I personally learned a lot. I think a lot of people in the audience learned a lot. There was a ton of Q&A, and we had a lot of fun. And so it's my pleasure to introduce him back to IOH to do a Firehose 102. And with that, I will love for you to unmute your mic and introduce yourself, Matthew, and I'll share my screen.
Hi, Abel. Thanks very much for the warm welcome, and happy to be back doing another presentation on Firehose. So based on your feedback, we'll keep doing these presentations as long as there's interest. So yeah, I enjoy putting these together and sharing with the community. So for those of you who did not see the last presentation, I would recommend going back and reviewing it. It's on the Indexer Office Hours YouTube. And yeah, other than that, let's go forward. Next slide. Oop. Okay, there we go. So I'm just going to do a brief overview of the architecture from the last presentation. But as I said, go back and review the whole details if you didn't watch it already. And then we're going to talk about setting up your first Firehose node today. And we're going to use Polygon as the example. But I will say that if you change a few things, you could run BSC or Goerli or Ethereum. Any of those would work fine with the same set of instructions. All right, next slide. So same slide as last time, just quickly, what is Firehose? It's a blockchain agnostic way of storing and retrieving data. Blockchain agnostic meaning doesn't matter if you're on Cosmos or Airweave or Ethereum, whatever, we store the data, and then you can use the same set of APIs no matter the blockchain to retrieve your data. So the blockchain Firehose will follow cursors backwards and forwards. You can, if you drop your connection, you can tell it to resume where you left off. Makes it easy for application developers. And the big thing is all the blockchain data is stored in flat files, which allows for massive parallel processing when it comes to doing analysis of blockchain data, which is going to be really important for us. All right, so next. So just a reminder, we've got 3 different binaries that we have to work with here inside Firehose. We've got an instrumented blockchain binary, or an execution layer client. We have a consensus layer client, and we have the Firehose binary itself. Next slide. So last time we saw this diagram, but I added some color to it for this time. So there's the black boxes, the execution client and the consensus layer. That's the same as before. For this exercise, we're going to merge all of the Firehose components into a single binary just to get us started, so make it a little easier. So rather than dealing with high availability and trying to do scaling, let's just do a simple example. So we'll put all this together. And we're not going to talk about the archive node or graph node in this presentation, but just a reminder, they do connect, and we did provide the configuration last time, so you know how to hook up your Firehose to your graph infrastructure. So that still applies. We're just not going to talk about it today. So if we take this diagram and we collapse all those light blue boxes into one, we get to the next slide. Voila. So this is the deployment model that we're going to do. All the Firehose components all together, and then we're going to hook it up to the execution layer client, which is hooked up to the consensus layer client. Next slide. Okay, so here's the links. Maybe somebody can copy paste them and put them in the chat of all the different things that we need to get going with Polygon. So we need those 3 different binaries. We've got the latest versions of everything there. Just to note about the instrumented, so consensus layer, I'm not going to talk about it. It's the same setup that you would already set up if you had a Polygon node. Follow the Polygon documentation. Nothing to add in value here, so I'm just going to kind of skip over that. For the instrumented Ethereum or ETH, Go Ethereum, whatever you want to call it. So if you look at the version number there, it says version Polygon 0.33-FH21. So the 033 is the upstream version that you would get from the Polygon Foundation. And the FH21 is the Firehose protocol version that this supports. So we're on Firehose protocol version 2.1, and we're using the 033 binary version. So the Streaming Fast team takes the releases as they come from released by Polygon. They add the Streaming Fast Firehose code into it, and then they do a release. So you always need to use the releases that are coming from the Streaming Fast team, not the ones that come, the original ones from Polygon. So very important, don't try to run the original one, it's not going to work. And then you need the Firehose binary. This is the latest version is 133. There's all regular releases by the Streaming Fast team, and Anna gives us updates every week when there's a new version. So we need that one as well. We also need Prometheus and Grafana. I'm not going to describe how to install Prometheus or Grafana. Feel free to Google how to do that, but I will give you the relevant information on what you need to do to set it up. Next. Okay, so here's the config. Very, very complicated. Not. Okay, so this is just one YAML file, which has all the configuration you need to run Firehose. If you create this YAML file, put this in it, and start Firehose, everything works. That's it. End of discussion. Great, we can finish early. No, kidding. Okay, so let's look at it in one piece at a time here. So you can see at the start, what has the word start? And the start means that's the piece of Firehose we're going to run. So Firehose has a bunch of subcommands. So the start subcommand is the one that actually executes everything. So we're going to configure start. And we're going to run a bunch of different modules. We're going to run the merger, the Firehose, the reader node, the relayer, and the index builder. And if you remember the diagram from a couple of minutes ago, that was all the pieces on the diagram. So yeah, so we're going to run all of those components in one Firehose binary. And then we're going to provide some flags. So where do we want all the data? Feel free to customize this as you want. Put the data where you want. We need the chain ID. So Polygon is chain ID 137. So we need that here. We need the execution layer client. So wherever you happen to put that there, user bin GETH. And then we need all the arguments that we're going to pass to that in order to get it to work. So, all the rest of the config file is just command line arguments that we're going to pass to Go Ethereum. So that's all one big long line there. I just wrapped it so it fits on the slide. So any questions so far? Nothing too much. All right, let's move on. And I should say, can you just go back a second? So if you want to run a different blockchain other than Polygon, hopefully it's clear from what I explained here, but you need to change the chain ID to whatever the ID is of the other chain, like Ethereum or BSC or BNB they call it now. And then you need to change the arguments that you're going to pass. And other than that, the configuration is basically the same. Okay, let's go. Okay, so now we're going to start. So user bin fire ETH. So fire ETH is the Ethereum version of Firehose. And then pass -c for the config file. Wherever you put the config file, feel free to put it wherever you like. And then start. So we're going to tell it to start. Once it starts, away it goes, and it should start trying to connect to peers. And it will create a data structure for you where all the files are going to go. So in the last presentation, I didn't mention the file hierarchy, but I did print it out here. So you'll notice there's kind of two subdirectories. There's one called reader, and there's one called storage. So the reader is a temporary storage, which would always be local on the file system where the reader component is running. Now here we're running all the components, so you're going to get all the directories, but that would just be specific to the reader. So as it's reading the blockchain, it's writing out one file for every block that it finds. So it writes it on the local disk. Once it's synchronized to the local disk, then it will push it into the storage system. In this case, we didn't configure any fancy storage system, so we're just using the local file system to write the blocks. So everything that's the shared file system, in this case, we're not sharing it because it's really all local. But the storage subdirectory is where all the shared files are going. So you can see there's a directory there called one blocks at the bottom. So once the reader creates all the blocks, as it's finished it, it will write it to the work directory, and then it will move it over to the storage one blocks directory. When the merger runs, it's going to read the files from the one blocks directory, merge them into a file and put it in the merge block directory, and then delete the files from the one block directory. So you'll be able to see all the operations happening on disk, and everything's just local for you. Next slide. Yeah, we're not talking about substreams here today. We'll do another presentation on substreams. All right, so hardware requirements. Hardware. So look at really the best advice here is look at the hardware requirements that you're given by the blockchain in question that you want to run Firehose for. So I just looked at the Polygon wiki page, and they recommend 64 gigabits of RAM, 16 CPU cores, 5 terabytes SSD, and a gigabit per second network bandwidth. So that's kind of your base requirements. And then we're gonna, we need to add storage capacity for the Firehose blocks. We need a bit more CPU potentially for, processing all those blocks and serving it to the end users or graph node or wherever it's going. If you don't have many users, then you don't need that CPU, at least at this point. If you just configure a node according to the Polygon specifications here, you're good to go. So you don't need to really add anything other than the storage space for the blocks. Okay, next. Okay, so just looking at the storage space. So you need a full node. So that's a terabyte and a half or so. You need 3.5 terabytes for the Firehose merge blocks, and then the search index is 100 gigabytes. So I did put on the next line under, I did provide some details about what kind of storage. NVMe, PCIe, LZ4, whatever. Get fast storage to run your Polygon node. The merge blocks and the index, that can be on, much slower storage, just based on what you need. So we actually store things on HDD in a big HDD array. So on a big array of spinning disks, works fine for storing merge blocks. Okay, next. Okay, so now if you want to get started and you download and you have the latest Polygon snapshot, that will only generate the Firehose blocks from the time when you have your snapshot. It does not generate all the blocks from the Genesis. If you want all the blocks from Genesis, you need to start Polygon from Genesis. So this confuses a lot of people. They think, oh, I'll just get the latest Polygon snapshot, download it, put it there, and then magically I have all the blocks. No, it does not work that way. So Firehose needs to generate the block as the blockchain is synchronizing, kind of in real time. So if you want blocks from 2 months ago, well, the blockchain needs to run from 2 months ago. So this means that the startup time to get Polygon running is, well, significant, let's say weeks or months, because you need to synchronize the chain from Genesis. And this is the same for any of the Ethereum-based chains. The Firehose needs to read the blocks as it synchronizes the chain and generate the one block file, which then gets merged into the merge block file. Obviously, this is less than convenient for getting started. So on the next slide, guess what? We'll have a friendly indexer who can help you with getting started. So here we go. We put all the blocks, everything you need is on our FTP site, which actually it's a little busy right now because a bunch of people are downloading Arbitrum data. But here you go. If you download all the blocks, so all the Firehose blocks since the beginning up till February 11th are available on the first FTP link, and the full node backup from February 9th is also available on the second link. And the full node backup needs to be before the last block that you download so that you don't have any holes, right? So you need to make sure there's no gap in there. So as the merger runs, when you start with these two sets of configuration, the merger will notice that you already have the merge block and it will throw those away. And then as it progresses past the point where you have the merge blocks, then it will start creating new ones. So I did provide the detailed command line on how to mirror the files. Make sure you run multiple in parallel because there's a lot of small files. So if you download one file at a time, it will take a long time. So but anyway, run the multi-parallel process to download all this data. So with this, you should be able to get up and running much faster than synchronizing all the blocks since Genesis. Next. Okay, but once you download it, probably you should not trust that I gave you the correct data. You should verify the integrity of the blocks that you have downloaded. So one of the things that Firehose has is it has tools. So we talked about Firehose Start before, or FireETH Start. This is FireETH Tools. And all of the Firehose commands actually have a help. So you can say FireETH Tools help, and then it says, oh, one of the commands is check. FireETH Tools check help. And it will give you more details. So get used to this because there's like 100 different flags that you can pass to FireETH, and they do various different things. So get used to using the help command to figure out what you need to do. So anyway, so we can verify the integrity of all the blocks that we downloaded using FireETH Tools check merge blocks, which you give it the directory where the merge blocks are. You give it S to actually read the contents of each block file, open it up, look at all the blocks, make sure that they link one to the next. And then R0 : means start at block 0 and go to the end. So you can run this command on only a segment of the blocks, or you can run it on all the blocks. If you just want to check that all the blocks are there, but not check the integrity of the block itself, you can leave off the -S flag. But I definitely recommend check that you actually have a valid set of blocks, that they all link one to the next. Next. Okay, let's talk about Prometheus. So here's the all of the Firehose components publish data into Prometheus, and it publishes 3 interesting metrics for you. So head block number. So where is it at the block at the current time? Head block time drift. So take the current time minus the block time, and that's the drift time. So this is really easy to allow you to generate alerts if Firehose is out of sync, because you can just say, if the amount of time is more than X amount of seconds, then generate alert. And then there's a last one, which tells you whether the component is ready and it's serving data on its gRPC endpoint. So that's a yes, no kind of flag. The thing to note is that the merger lags behind the other components. So like the reader is reading the data from the blockchain, so it's going to be the most up to date. Then it's going to get relayed, then it's going to get merged. So each one of those components is keeping track of where it is in the time. And the merger needs 100 blocks. And then once it gets 100 blocks, then it kind of goes up to the next one. Then it waits till it has 100 blocks and goes up to the next one. So merger is always slightly delayed. So set a slightly less aggressive threshold on the merger compared to the others if you want to generate alerts. And I just, if you want to configure the different endpoint, just run fire eth start -help and look for the metrics related options, and then you can just add those to your config file. But by default, Prometheus is enabled, so you don't have to set it up. Next. And then this is just a quick Grafana visualization of that all-in-one node. So I just started a Prometheus, or I started a Firehose a couple of days ago just to make sure that all the instructions that I'm providing is actually working. And then I just grabbed a screen capture of it. So you can see each of the components is listed on the right side there. It's like block indexer, Firehose, merger, reader, relayer, etc. So you can see the status of each one. Next. Okay, so after you get everything running here and you download all the files, you have everything working, then what do you want to do next? Probably you want to create a container or a systemd unit file to run your Firehose binary. The systemd unit doesn't have to be anything very complicated. Just tell it to restart if it fails, is probably the main configuration. You do want to prune your Go Ethereum node on a regular basis. So a full node keeps all the state. You don't actually need all the state, so you can prune that off. So feel free to run the pruning. You probably want to do backups or a ZFS snapshot, especially for your Go Ethereum node. So if for some reason you end up with a merge block that goes missing or a one block that goes missing, and then we can't create a merge block, well, you might want to try rewinding the chain, or if you've got a backup, you can go backwards and then play again forward. So you want to consider backups, and then of course you don't want to lose all your merge blocks if the disk dies. So consider where you're going to back those up. Once you got that basically working, then you can think about setting up a high availability solution for various components. And I just as a reminder of how many you need of webs. Yeah, and then don't forget to open your firewall part and your Go Ethereum node. Don't start sending piles of queries to it because the whole point of running that node is for the purposes of generating Firehose blocks. So better to not overload it trying to do something else with it. So just keep it for what it's meant to do. Next. Questions? Okay, there's like piles of questions here in the chat, which I have not yet read. So I will, maybe I'll start at the end and work my way backwards. Okay, so is it possible to just fill the gaps without reverting? No, the blockchain needs to replay. I mean, the Firehose blocks are generated as the chain moves forward. So you need to go backwards in time and have it replay the chain. So revert to an old backup or, force the chain backwards. What frequency do you run ZFS snapshots? Do you keep a few generations? So we do twice a week. We generate a backup, and yeah, we keep at least a few. Because if something goes wrong and you need to redo something. We actually have quite a lot of backups because if for some reason there's a protocol change in Firehose and we need to regenerate every single blocks from the beginning. Well, actually, we don't want to resync from Genesis. So if we keep a backup, say, once every 6 weeks or so, then we could start running all those in parallel and then generate all those blocks in parallel. And then we could replay the whole chain and regenerate all the whole history, without waiting for it to sync from Genesis. So I saw there was a question earlier, like, how long does it take to sync from Genesis? I actually have no idea because we've actually never let it do that recently because we keep all these backups. But that does require a lot of storage space. So if there's a friendly indexer that you can share blocks with, that's much easier than keeping all these backups. But yeah, we actually have a lot of storage space allocated to all these backups of the Go Ethereum. Okay, what else? Yeah, so substreams, yeah, we're going to talk about substreams in a future session. Okay, another question, how long does it take to run a check from Genesis? Well, that really depends on the speed of your storage. So if you're going to check all the blocks, maybe, a day or something. But feel free to run that in parallel. So if you want, I wrote a little shell script which just chunks it up into like 1 million blocks chunks, and then run the checks over 1 million blocks at a time, and then you can get it down to a couple hours. But basically, the time is how long does it take to download the block from your storage, which if it's local, then that's fast. You need to decompress it. You need to read all the transaction data that's in the block and validate that it's not corrupted. So, but yeah, definitely try to run it in parallel. We did submit a PR to the Streaming Fast team to add a parallelism option to the check, but it's not merged yet. So hopefully that will come along soon. But yeah, feel free to write a shell script. Just make sure if you're going to write a shell script, make sure there's an overlap so that you're not forgetting to check the boundary from when you start, when one finishes and the next one starts. So make sure you have at least one merge block overlap so you don't miss that. Any other questions?
See a few people type.
What problems happen most frequently? The normal problems is the blockchain problems. There's an upgrade. You got to keep up with the upgrades, right? So if there's going to be a hard fork, you got to make sure you keep with that. Is it peered? Is it generating the blocks? That's the main problems with running Firehose, but that's the normal thing that every indexer has to deal with, whether you're running Firehose or not. There was a little discussion earlier about holes, or so if something goes wrong, then you end up with having to try to rewind the chain or something. So in Ethereum, it's not so bad. In other chains, it can be a problem more than here. So the Streaming Fast team has done a really good job of trying to make it so if you stop your Go Ethereum from running and then you start it again, it doesn't miss a block. But it could happen that a block gets missed. So if you're running 2 readers and you don't restart both of them at the same time, then you're good because the other reader will cover any holes compared to the one that you're restarting. So I highly recommend running 2 readers or 3. So that way you can do an upgrade everything stays online, the other reader keeps going. So there is quite a bit of infrastructure required to run a good quality Firehose infrastructure. So, and as I said, Ethereum is pretty good, but you might get into other blockchains where, well, when you restart a node, it's going to have a hole and there's nothing you can do about it. So in those cases, you need two readers, or you need a backup that you can roll back and then go forward. So file system suitability. Okay, the good question. So one of the things we tried, okay, so first thing, there's a lot of files because there's a file for every 100 blocks, right? So think about if you're going to try to store this on NFS. I haven't tried it, but yeah, maybe I don't know how fast NFS directory listings work. Might not be fast enough. So really do some benchmarks before you pick a file system. Now you've got, lots of Polygon blocks to play with, so you've got a good test case. But yeah, watch out for those remote file systems and how they perform. I also tried Mini-O or Mini-IO, I don't know how you pronounce it, which is an S3 compatible storage thing. But they seem to have problems with, lots of files into one directory and doing directory listings. It seemed to be very slow. Maybe they've improved it since then. I had a lot of discussions with developers about it at the time when we tried it, which was like about 2 years ago. Anyway, it didn't work. So yeah. So we ended up on Ceph. The Google Cloud Store should be fine. Amazon S3 should be fine. Yeah, but yeah, do some testing or ask, the rest of the community if they've run a specific configuration, and then, their experience. But yeah, it's not easy running, this kind of infrastructure. So we're using Ceph, and we're using the object storage with the S3 interface in Ceph, and it's working reasonably fine. When I said dedicate the Ethereum RPC client to Firehose, as far as I know, there's no negative impact if you query it, other than maybe you're going to slow down generating the Firehose blocks. And one of the things that we're trying to do with Firehose is make sure we get the output as fast as possible so that we can serve that to our GraphNode clients. So you don't really try not to send anything to Go Ethereum if you don't need to. Don't try to, put the archive mode enabled in Go Ethereum and then send all the RPC calls from GraphNode to there. Definitely not. Have I had any issues with Ceph specifically? Ceph issues, yes, we've had lots of challenges with Ceph. I could probably do a whole session on that. I guess the key thing to think about there is to store all of your index data on NVMe. Also, your database for all your storage needs to be on NVMe, and then you can store all the actual blocks onto the HDD storage. So one of the things that we ended up having a problem with is, just the amount of reads and writes. Every one block is written into Ceph as the blocks happen. And we're running like 20 blockchains or something. And some of those blockchains run at like 0.5 second interval blocks. And we're also running multiple readers for each blockchain. So the number of files per second, starts getting quite high in the hundreds of files per second that you need to write into Ceph. You want to think about the scalability of not just when you're implementing Polygon, but say you're going to run 50 blockchains with Firehose later. You need a scalable solution. And then the other thing is substreams. When we get to substreams, but we're not covering substreams, we'll store its cache data in your object store as well. So feel free to think about that from a storage perspective. But yeah, if you want to have a longer discussion on Ceph, we can talk about it through this session. I have not tried JuiceFS, but yeah. So feel free to choose your storage, but do test it before you just assume it's going to work. We have a lot of those NVMe drives. A lot. But all right. If you have more questions on Firehose, feel free to ping me in the Indexer Firehose channel. Just tag me directly, and then happy to answer any questions.
Wonderful. Thank you so much, Matthew. Really do appreciate that. And yeah, as Chris has done there, he's tagged Indexer Firehose, so please do check that out. Another thing that Chris has also mentioned is a question that Mark and Andre has asked about QoS data for Avalanche on the 17th. If it's okay, I'd love to direct that to you, Nick. Would you like to respond to that there? You seem to be unmuted, but we couldn't hear you there.
Yeah, I'm having some issues here. Can you say that question one more time?
Yeah, sure thing. Let me just go ahead and pull it up again. He asks, are we going to have QoS data for Avalanche on the 17th? Reminder, it's important to build confidence into scoring methodology and to allow participants to learn and improve.
Got it. So I am posting that to the team that's handling that, or I should say the members of the team that are handling that. So I don't have a response now, but I will get back to Marc-Andre and provide a response.
Wonderful. Thank you so much. And there you have it, ladies and gentlemen, another very successful episode of Indexer Office Hours. Thank you all for coming along and listening. A special thank you to, of course, Matthew for sharing all of his insights on Firehose. Again, another very insightful conversation. And as always, we're going to post this up onto YouTube. So if you want to revisit, please do. And obviously, the slides are in the chat. So feel free to go check that out as well. Thanks, everyone. And we look forward to seeing you all again next week. Take care. Bye-bye.